Okay, so I should be recording with a mic. Oh, I should probably use my fancy microphone. Well, yeah, well, no, I'm not gonna mess with that today. Maybe for next time. And I need to mute my own loopback. Actually, I have that. So let me go ahead and plug this in. I have the stream up just because I don't know how to do chat because I don't know what I'm doing. So I've got myself on like a 10-second delay. Let's see. So I've got this. Can I get this in screen without it being terrible? My cheap condenser mic. Oh! There goes the condenser mic. How are you? Okay, so I've got the condenser mic. Let's switch this over. Okay, how about this? So now I have to wait 10 seconds to hear myself. Okay, that does sound way better. Let's try and get this slightly out of the screen. Sorry for the earthquake noises. Okay, if I have it here, is this okay? Yeah, it sounds a little echoey, but it's not terrible. Sorry, I'm waiting the 15-30 seconds to hear myself on loopback. Okay, so I'm actually going to close the YouTube window because just sitting here idle, I'm using way too much CPU. So I'm just going to go ahead and kill that and hope that makes my CPU usage better. Okay, so that's gotten rid of the window, so I won't be able to hear myself anymore. Also, if you're streaming this and you want to chat with me, I'd recommend joining the Rust embedded IRC room because I have that pulled up in a window, and I'm going to be probably looking there. I don't have that on screen, but I can always throw that onto the screen if I need to. Yeah, okay. So first stream went fairly well. It was recorded, so that was kind of easy, but this time I'm actually trying streaming, and I'll see if it actually works for me. But last time we got our project set up. We got Travis CI set up for at least making sure that we can build things cleanly. And we got a basic blinky light using both the NRF HAL and RTFM. Ran into some problems last time because the BSP crate, so the crate for the DWM 1001, it was trying to be helpful while RTFM was also trying to be helpful. So I opened up an issue there, and I've been talking to Hano about that. And I don't know if there's going to be an easy answer for that. So for right now, probably what's going to happen is we're going to keep doing what we did before, where we copy and paste any code that is needed, which is kind of lame, but I'm still happy that Hano of Braun Robotics was able to get so far in setting up the device. So even if I do have to copy and paste, at least it's already written, and I don't have to worry about that too much. So I've got my DWM 1001 dev board. I know some people in the chat said that they bought some, so maybe they're following along and they can follow along with this while we're doing it. But my goal for today might actually be a little less embedded code. So there's two things I want to get. Well, the thing that I want to focus on today is logging. So for developing embedded systems, debugging is great, and it helps you as long as you're attached to the computer, but debugging can mess some stuff up with timing. So having good logging is always a good thing. So we're going to start with figuring out logging over the serial port. So on this board there is a normal UART that's wired out to the debugger chip, and that's passed through via USB. So anything that you send over a serial port will show up in the USB serial on the device itself. So we're going to use that. Eventually we may end up doing something else, like once we have these devices not plugged into our computer, we might be sending these debugging messages over wireless, or we might be keeping them in RAM in case something bad happens, and then we might write them to flash. So there's a lot of different ways you can do logging on an embedded system. Depends on how connected you are and how reasonable it is to send messages, especially if you're in your low power mode. A lot of times it doesn't make sense to send messages because either having a serial active isn't great, or even using the radio is even worse. So maybe you'd only use that if you had some kind of critical error or something like that. But to get this working, so there is currently support for the UART, or the UART E. I think the E is extended or improved, or not improved, but some kind of fancy UART that is on the NRF52. We have a blocking driver, which means you can just send stuff, and I think on the 832 it's limited to sending 256 bytes per transaction, and that's just how the DMA hardware on the board works. So for on the NRF52, essentially everything has to be DMA. So even if you're sending a blocking transaction, you kind of do DMA and then you just block for the code to be done. But for logging, we probably don't want that, because even at 1 megabit, which is the max speed of the UART for the NRF52, it still takes way more time to actually send data than it does to prepare the data. So we would spend a lot of time just sitting around doing nothing, which is not great, especially once we have wireless communication and we're trying to hit certain timing slots. So I'm going to try and clean up the pull request that I have that uses a crate that I wrote called BBQ, which is like a first in, first out queue that's really good for DMA. So I'm going to see if I can get that PR cleaned up so that I can use that. Probably put it behind a feature flag, because we haven't really decided whether we like the UI that it provides, and I'll explain a little bit more when we're looking at that code. The other thing I want to look at, so I'm going to talk a little bit about framing. So let me open up a new text file. So we have a UART, and a UART is essentially separated two streams of bytes. So you've got the stream that comes from if you've got the device, that's going to transmit data to, right now it's going to be my laptop. It could be anything else, but for right now it's going to be my laptop. And then we also have a stream of bytes going the other direction. So it's two pretty much totally independent, streams effectively, and they're streams of bytes. So we're going to be using that for logging, and there is a concept of something called framing. So if you were to send a UDP message, that's a datagram, which means you're sending essentially a packet of data in a single message. And it's possible to see where that message starts and ends because you're sending a packet, and UDP handles the framing for you. TCP is a stream-oriented protocol, but you can send streams of bytes, but because of the way that TCP works, essentially you're always guaranteed to get every byte that you send or receive. And unfortunately with the serial port, I've seen this one particularly, when you use the maximum speed of 1 megabit, it drops bytes, which is not great. And I could I think I tried lowering it down to 115,200, and it didn't seem to drop any bytes there, but maybe I just didn't see any or they happened less often. But this is kind of a normal thing over serial protocols, is that no wire is perfect and there's no lack of signal noise, especially if you're in a really noisy like magnetic environment. So it can be possible to lose or corrupt bytes. So to get around that, I would like to, so when you're doing logging, there's a couple ways that you can kind of split different log messages. Kind of the simplest way is you just put a new line. If you have purely text that you're logging, you can just put a new line after each message, and even if you've corrupted a byte, a human's still probably going to be able to read them. If you're parsing your logs with a machine, it will probably get confused if one of the bytes is corrupted or missing, but to a human, even if a couple bytes go missing, it'll still look good. But the problem with this is if you want to send some binary data that doesn't map into ASCII, you either need to do some kind of encoding, like base 64 encoding, or convert it to hex or something like that, which is not as efficient as just sending the bytes over the wire. And I think in the future, likely over this UART, I may end up treating it like a modem, which means I'm just going to be taking the packets from off the air and sending them over USB, and then if I want to send packets from my computer, I will send them back over USB. So I do think it could be possible that I want to use binary data over here, which is not going to work super well with our UART. Which means that I need to be able to do a couple things. I need to be able to tell where a message starts and ends. So if I want to feed this message into like Serde or something like that, or Serde, I need to tell it like, hey, this is the message, and I want you to parse this message into JSON, or using something like SSMarshal, or even if I got fancy and use something like protobufs, then I need to know where each message starts and ends. And I need to be able to at least detect when a message has had some bytes go missing or corrupted. So I need some way to frame messages. So this says like this message starts here and this ends it, so it's framed by that. I need a way to detect missing bytes. So if just a serial port just decides to drop one of my bytes and it goes missing, and that would corrupt the message, or just corrupted messages. And overall, I want this to work really well with DMA, because I have DMA hardware on here, which means I can let the hardware handle the sending. So DMA is direct memory addressing, which means in practice you can have a chunk of your hardware go out and do something directly for memory. Usually it's either reading or writing data. So with this UART that we have, I could put 128 bytes of data in memory, and I could tell the serial port, hey, 128 bytes starting at this memory address, go send it out at normal serial port speeds. And it will kind of automatically handle that, and I don't have to sit there with my CPU and be like, putting one byte in at a time. Same for messages coming in. I can say, hey, I expect 32 bytes coming in, and I would like you to put them here. Go and notify me when you're done. And when I say notify, you're probably going to get an interrupt, or you could be checking the flag in the peripheral that says, hey, I've received all of that data, or I've received some of that data, or I'm halfway done, or things like that. And I want to be able to do this because it allows me to go off and do something else with my CPU, and that might even just be going and listening to radio packets or something like that. But I don't want to be sitting there, and if I want to send a kilobyte of data over the UART, I don't want my CPU sitting around for the amount of time that it takes to do that. So whatever I have for this message protocol that I'm coming up with needs to be friendly to DMA, doesn't use a lot of CPU, those kind of things. So I'd actually seen another technique at companies that I'd worked for before called byte stuffing, which means you use some special ASCII characters. So there's actually a couple ASCII characters that already exist. They're from like the original serial port or modem days, and you've probably seen them on an ASCII on an ASCII table before, but didn't know what they were for. But specifically, I'm talking about DLE, STX, and ETX. So this stands for Data Link Escape, which says, hey, this is kind of a special control character. I'm about to send you some like control of the protocol over the data link, and the serial port is a data link. Start transmission and end transmission. So the idea would be that at the beginning of a message, you type DLE, or you send the byte DLE, you send the byte STX, and then you send all of your data. And then when you're done, you send DLE ETX. And that says, okay, I'm starting the transmission, everything that's in there is the data, and then at the end I expect DLE ETX. And this works really well, but you have the same kind of problem that you have with new lines, in that if you were sending some binary data and you happen to send either DLE or ETX or something like that, it's going to get confused, because it's going to be like, oh, I'm getting a command now. So in order to get around that, you do a concept called byte stuffing, or you use a technique called byte stuffing, which says anytime that DLE just randomly shows up in the data, you precede it by DLE. So it's kind of like if you've ever had a backslash. It's kind of like, normally if you had a backslash and then some character, it might treat that as a special character. But if you double backslash, it just treats it as kind of the text \x. And this is exactly the same kind of thing. So if we had some kind of data that was, some data, and then DLE just in the binary happened to be there, what you would do is on the way out, you would escape it with another DLE. And if you had two DLEs in a row, you would just double that up. So in the worst case scenario, the bytes that you send over the wire might be twice as many as your actual data payload, which isn't super great because that takes more RAM, and it doesn't play super well with DMA, because if I have my data that I want to send, 04, 05, 06, and let's say, I don't know what DLE actually is, but then whatever DLE is, and DLE, and then 04, 06, DLE, this is the actual data I want to send, then I'm going to actually have to walk through that data. I'm going to have to copy it into a new array. I'm going to go, okay, this is fine, this is fine, this is fine, this is fine. Oh, that's a DLE, so I need to put an escape there. Oh, another one, so I need to put this there. 04, 06, DLE, DLE. Then I can do my DLE ETX. And actually at the beginning too, I'm going to have to put my DLE STX. So I actually have to like scan through that there, which means, yeah, the sending is going to be automatic, but I'm probably going to have a lot of copying, and it's going to be kind of annoying, and I either need to like kind of incrementally do that, or I have to like slide everything over every time I need to insert a DLE, which could be expensive depending on how many bytes I'm sending. So I went online on Twitter, and I bothered a very smart person named White Quark, who does some really cool FPGA and low-level hardware stuff, and she kind of pointed me in the right direction of, I was asking, is there a smarter way to do this? Is there kind of like a technique that's 15 years old and I should know about it, but I don't for some reason? And she pointed out, yes, there's a technique called COBS, which is a consistent overhead byte stuffing. And this uses a similar kind of technique, but it does it in actually a pretty cool way. So in COBS, you don't have to use 0, but most people use 0. So you use kind of like the null byte as your frame separator. So essentially a 0 means this is a segment between frames. So if you see a 0, the next byte that comes in is the beginning of the next message. But the problem is, when you're sending binary data, you're fairly likely to see a 0. So if you were sending some data that was something like 00, let's say 01, 00, 02, 03, 00, 04, 05, 06, 00, 10. And this was the byte I was actually sending. Let's say it was some struct with some values in it. So you're going to put, at the beginning of every message, you are going to put, there's going to be the 0 beforehand that says this is the end of the previous message and the start of the next one. But you always put one byte at the front. And the byte at the front is one of two values. If it's between 1 and 254, then it means the next 0 that you're going to see, or excuse me, this is how many bytes until the next place where there would be a 0. And essentially it kind of treats it like a linked list of zeros, and it replaces all of those actual zeros with how many bytes until the next 0 or until the end of the message. So here we've got kind of space here because we don't have our so this message becomes something like, I think it's 0201, and then here we need to calculate how long until our next 0. So we've got I think it counts the current byte, so it's 1 2 3 4, so this would be 04. Let's see, 02 01, yeah. So this 0 became 4. So now we're not sending a 0, which means we don't get a weird terminator there. And then the rest of these bytes are totally the same. And then when we get to this 0, we need to count 1, 2, 3, 4, 5. So 05, 04, 05, 06. This is our next 0. So then we need to, there are no more zeros in our message, so we need to mark when the end of the message is going to be. So I think it's 1, 2, can't remember if it's 2 or 3 here. I'll have to look at the spec or things like that. And then we get our 00, where this is like the end of the message, and this is kind of the fixed header that we put on there. And if you have a run of 255 bytes where you have no 0 in there, then you're just going to put F, like this would just become FF, and this, then you're going to put another header byte at that location, basically to just pick it up. So you know that you're going to throw that byte away if you were decoding it, or if you were encoding it, you knew you were going to have to shove in another byte there. This is really nice because we do have to scan through the message that we're going to send. We do have to kind of mangle it a little bit, but almost all of this can be done in place. So what we're probably going to do is, I don't know, write some code that finds the first 0 or however long it's going to take, and then in our output buffer, we're going to push that byte, and then we're going to push all of our other bytes, and then we're going to go through and mangle, like replace all of the zeros that are in there with these kind of byte offset things that we have going on, and then at the very end we're going to shove a 00, which says, hey, that was the end of the message. So this is what we're going to do for framing. So this is for framing. And it's also nice because you know how many bytes until either the next 0 or the next end of message. If you were still counting to 3 or to 5 or to 200 and you got the 00, you knew that you lost a message. Like, you've become out of sync, and basically that message is corrupted, and there's, I mean, you could probably log that you received a corrupted message and maybe someone could try to decode it. But the computer can just move on and say, hey, nope, just lost that one. Sorry about that. So that prevents us from running into dropped bytes, but that doesn't help us with corrupted bytes. So what I'm probably going to do is I'm going to throw in a CRC32, which is just a cyclic redundancy check, which is some math that you can do where you kind of apply certain math to every byte in the sequence, and you get a checksum out at the end. So it's kind of like hashing, or it's very similar to hashing. So if you ever hashed a file and got like a SHA sum, or if you've seen that in Git, it's very similar kind of technique. It's a different algorithm specifically. Like they use SHA-1 for Git. They use we're going to be using CRC32 because it's pretty simple to calculate in software. So it's not going to be a lot of overhead to calculate the CRC32, and we may even be able to do that while we're walking over our message. So we might be able to do both things at the same time while we're applying COBS and calculating CRC, so we're only iterating over our array once, hopefully. So we'll end up with a message that has something like the COBS header. Because I'm going to send a bunch of different kind of message types, think of this kind of like an enum. I'll probably have some kind of like message ID that says, hey, this is a logging message, this is an error message, this is a binary packet, or something like that. So I have that, and then I have probably whatever data, and it can be variable length because I'm just going to keep going until I see that 0, 0. And if it's the wrong number of bytes, then I'll know that when I go to decode that based on the message ID. And then I'll probably have my CRC32, which is going to be 4 bytes. And then we're going to have our COBS footer, which is OX00. So in all, we're kind of adding a fixed overhead of, let's see, 1, 2 plus 4, so 6 bytes over, if we just sent the bytes over the wire, and just kind of hope that we always were in sync, like our laptop and our embedded device were in sync and they never lost a message or corrupted a message. Plus maybe 1 or 2 or 3 or 4 bytes for the message ID, probably depending on how many message IDs we have. But the idea would be that for this chunk of the data, we're going to use some kind of tool to automate this. I don't want to write my own parser, or I don't want to manually write data. So we might use something like Serday with SS Marshall. So you've probably used Serday before for, let's say, you write a struct in Rust and then it turns it into JSON auto-magically. And I like this. And there are some no standard. So Serday itself works in no standard, which means we can use it with microcontrollers. Problem is something like Serday JSON does not work with no standard. It requires the standard library because it does heap allocations and things like that. There are a couple of Serday compatible crates like SS Marshall, which are much simpler, and they're meant for sending binary data. I think SS Marshall specifically is for sending messages between kernel contexts or something like that. So they're not using it for bare metal systems, but they're using it for operating system development. And yeah, we have the same kind of situation going on here. So I'll probably start with SS Marshall. I know there's some alternatives to this that we can use. For example, in C before, I've used a thing called NanoPB, which is protobuf for microcontrollers, where you can still use the same specification for defining messages. So protocol buffers is a tool from Google where you declare data formats in this other syntax, so the protobuf syntax. And it generates code in all different languages for parsing and for serializing and deserializing that, which is really handy if you have like a bunch of microservices and some of them are in Python and some of them are in Rust and some of them are in PHP or whatever, and you don't want to have to write that code multiple times for sending messages back and forth. Protobuf is great for that. NanoPB is nice because it will generate C code for you that works on bare metal, so it doesn't do any allocations and things like that, and it's fairly like compact, the amount of code that it generates. And you can parse messages. I've done that with a device that communicated over a wireless serial link or a wireless protocol, and we use that to talk between our embedded system and a desktop or a mobile phone or things like that. So we used that, and it worked out fairly well, but it's going to generate C code. As far as I know, I don't think you have a Rust version of NanoPB yet. And I really actually kind of like Serday because I would like the idea that I want to write this protocol code once, and I want it to run on my laptop, and I want it to run on my embedded system. So that's really the idea, is that I can share code, and on one side maybe I get a slightly more convenient interface because I can use the standard library and stuff like that, and on the other side I don't, but that's okay. So the idea is to use something like Serday or SS Marshall. Japark has also written a cool library called UJSON, so MicroJSON, where he's got some much leaner parsing and serialization of JSON data. So we may take a look at that too, just because using JSON is a little more verbose, but it's easier for a human to read until I have tooling that does all of this. But the idea is that at some point, like today, it's probably going to be sending text, which means what I'm doing today is total overkill. Just explaining it took a lot longer than it probably would take to just write some text to the UART. But this framing thing has been something that bothered me, and I just learned about COBS, and I realized there actually is a Rust crate already that is no standard compatible that does COBS, which is awesome. But it doesn't handle streaming data. So if you only have like the first 10 bytes of a 20 byte message, it's just going to fail to parse that, which means you need to kind of buffer that up until you get a 0 and then pass it all in, which we could do, but since we're running like a DMA driven thing here, the idea is that we should be able to handle streaming. So I'm kind of halfway through implementing streaming support for that repo. So that's probably what we're going to start with today. If I get that up and working, then maybe we'll go look at the UART stuff. Or if I get really frustrated with this COBS stuff, maybe we'll bail and just do text UARTs, or I'll just do batches of data to send out. But at least for logging, it's pretty easy because I only need to serialize that, because at least for now, my device isn't receiving messages. It's only sending messages, which is really nice. So I'm going to go ahead and, so I have this pulled up here. I was looking at a bunch of stuff between our last stream and now. So I've got some items in my Scratch repo, but I'm actually going to copy. You know what? I have a fork of the COBS repo. So this is that COBS repo, is that awelke COBS RS. So I think I forked this to the Ferris Systems repo, maybe? Yeah, so you know what we're going to do? We're just going to add this as we're going to make a directory. Well, let's do it up a directory. So make dir vendor. So I'm going to make a vendor directory just for while I'm working with versions of code that aren't published yet. I'm just going to have a local copy of it because that's easier and it'll make it, I plan to upstream all of my code, so I'm going to just keep it in here. I should probably peek at Twitter or YouTube to see if there are any comments, people yelling at me. So I'm going to pull up Twitter real quick. I don't see anyone chatting at me in the IRC, so I'm guessing no one's either watching in IRC or no one's watching at all, but I did see a couple people watching on YouTube. Let's see. There's one person watching me, which is probably just me. Okay, so cool. Early days. So mostly this, I'm guessing, will be consumed by people recording this, but if you are watching this still, then feel free to shout out in the IRC chat, and yeah, I can answer any questions. Otherwise, I'm just going to keep going on streaming the stuff I was going to work on anyway. Okay, so I can close that now. So in my vendor, cd vendor, let's go ahead and do a git submodule add. Let's add this COBS RS. And then I'm also going to go at, while I'm at it, let's add this as cd COBS RS git remote add upstream. This is going to confuse me when I push to master, but that's okay. So git checkout streaming. Okay, so real quick, let's git diff master. So what have I done? So essentially there's already, let me pull this up. So in vendor COBS search lib, it's really just one big file. This has my changes in there already. Well, let's fix that. Git checkout master. Okay, so now it doesn't have my changes. But essentially there is, an encode function, there's a decode function. It does have a feature for use standard, which means if you're using the standard library, you can do things like decode into a vector of U8s, which is super convenient. And then it's got some macros. Well, it's got one core macro that does the decoding and a couple functions that do the encoding. So it's actually sort of nice. Nope. So let's go back to my streaming. So far, what I've done is I've gone ahead and written a streaming encoder, So written a streaming encoder, which essentially took kind of the core code that was there before, and then just when you push data into it, it will essentially progressively build up, so it remembers its own state. It takes a mutable reference to a U8 slice, which means whatever you're sending it to, it'll keep track of that. And it'll keep track of kind of what the current state is. So if you push 5 bytes, then 10 bytes, then 20 bytes, it will still encode it correctly. So I've got that written, and I actually went so far as to replace the encode and decode functions assume that you pass in the whole source and the whole destination, and it's either going to work or it's not. But because we're going to be receiving stuff asynchronously, that's not going to work for us. So I've gone ahead and replaced the blocking encode or the blocking decode with essentially our streaming encoder and decoder. But essentially for encoding, it just pushes the entire source in at once, and then it finalizes it. So mine has the API of like you create an encoder which holds the state, and then you can push U8s into it, and then you can finalize it. And the code that was already there was already unwrapping everything because it would panic if something didn't work, so I just kept that behavior the same. And I actually got all the tests to get green for the encoder. But for the decoder, I haven't yet. Currently, if I do a cargo test, that's going to build. And it's going to build real slow because I'm streaming. But that's okay, because I'm going to go and look at... I'm going to pull up the Wikipedia page because I wasn't totally sure about... I think I had some off by ones misunderstanding of when you've got that link list of when the next byte is or the next 0 is. I think I had that wrong. So let's see. If you had 11220033, we've got our overhead byte, which says the next 0 would have been 1, 2, I guess it's not including that. So it's 1, 2, third one. So it's not including that. And then the delimiter byte goes at the end. Okay. So is that only for the prefixed? Yeah, so unencoded would be, if you've got 0, 0, you put your 01 there. This is that. Okay, because it's going to implicitly put the 00 at the end. I don't know if this encoder actually does put the 00 at the end. I should probably look at the tests, because there are tests here. So the test here, actually really nice. Excuse me. It's not putting the zeros in for you, which is good or bad, depending on how you look at it. So the way that these tests read is they have a test pair function, which takes, they do kind of like a loop back. So this is the data you put in, so this is your raw data. This is what it should become when it's serialized, and then it should go back to being this after you decode it. So they take this, encode it, should get this data, take this, decode it, and you should get this data back, just to make sure that you have a round trip decoding. So let me make sure my understanding of that is right. So this says, I've got a 0, so that says I should have 1, 2, 3. Okay, and then that is where it's supposed to be, and then 2, so it'd be 1, and then the 0 implicitly comes at the end. Okay, so I understand that now. So if we were decoding that, does this have like a step-by-step decoding, stuff data, unstuffed data? Okay. So some of these algorithms are really simple because they know that you can keep going until the end. The problem with at least this is there's some ambiguity that you don't really know, because when it says there are 5 bytes left, you don't know if you need to expect a 0 at the end, or if you need to expect another number. A 0 at any point means the end of the message. And if it is a 0, then that's the end of the message and you're good. Otherwise, if it is a non-zero number, you should keep going. And essentially, if it was 255, then you discard that number, because then you know this is like an extra header that you've had to put in. If it was any number other than 255, you need to take that number because it's a 0 that has been stuffed. Okay, so the way I approach this is I was trying to make kind of a state machine, but I was doing it late at night when I didn't have a lot going on. So I need to add this back in. So what I have here is kind of an enum of a state machine, and the idea is that the decoder holds this. Where I've got, let's just dot comment this because it makes sense. So this is state machine has not received any non-zero bytes, because technically if you get a bunch of 0 bytes in a row, that's kind of okay because it's not the end of any messages. They're just all 0-sized messages. Wait means we are waiting to see if the next what the next byte is, which I guess we don't. My idea for this was I missed the fact that if it was a non-zero number, then you knew that the message kept going. And I guess you could have exactly 255 bytes. Like the end of the message could be 255 bytes. I actually should check if they talk about that. I wonder if these are exactly the tests they have in this laptop. They're in this. Because I see, let's see, red is an overhead byte. So green is a 0 byte that was altered. Red is that, and a blue is the zeros. So it does look like if you have 255, you always have an overhead byte. So I guess this example is showing that if you have that, essentially that FF means that you have to have this there, which means the next one's going to be there. Okay, so if you're grabbing a, I called this, so wait, this wait state may need to go away. No, because it could be there, like we're about to grab. We might need a wait grab and a wait grab chain. So what I had in mind for grab, this is kind of that, the linked, or 1 to 254 bytes in that kind of overhead window, where grab chain is a full 255 bytes will be a header next, where 1 through 254 can be header or 00. Because I guess we really don't need wait, because we're just going to be in the 0th item of grab or grab chain, and we know that what should be there. So I'm actually going to get rid of this state. And then this is just prevent reusing the state machine. So the idea is that you, like, once you've processed a message or you've hit some kind of error condition, you just say, nope, I'm done with this state machine, because I only have one destination buffer. So you don't want to be like stacking messages in there. Okay, so with that understanding now, let's kind of totally rewrite my state machine, because it's probably bad. Let's do a layout of 2 columns, and let's make this one small, and I'm just going to copy my states over there so I can remind myself what my states are. Okay, I'm actually going to throw this away because, yeah, whatever. Okay, so I'm actually going to keep everything that was inside of it except for that match statement. Okay, the idea here is because we're borrowing self state, the idea is that we're always going to produce a new state every time we go through the state machine. And you go through the state machine, I've got feed and push, where feed is you put a single byte in, and push means you can put a slice of items in there. This just made this state machine a little easier. So if we're in idle, let's see, we're matching state and then data. So if we're in state idle and we get a 0, 0, then our return value is going to be, and what we return is an option of usize. So if we had gotten a byte, or if we had gotten a message and the message is done, we're going to return a sum and then how many bytes that message took up. Otherwise, we're going to report how many bytes we took up if there was an error, just so we know, like, oh, you can throw away this many bytes. So this is going to be an okay none, because, yeah. So what does he want? It was return value state. So we return an okay none, because if you got a 0 while you're idle, then this is just, it's like someone spamming the clear button. And then what was the second one? The state is just going to continue to be idle. If you get idle and any other value, that means we've just begun a sequence. Actually, next is going to be FF, because that means we're about to start a grab chain, which means we have an okay none because we haven't completed a message now, but we're going to use a grab chain, which means we're going to grab 255, and it's going to be another, there's going to be another header there, and we're just going to start with this because this says this is the number of bytes we have remaining to grab in this chain, and it's going to be 255. That might be off by 1, so we'll just note that. And then otherwise, idle n, we're going to have an okay none because we just got a grab with n in it. So that's how many bytes we have left. So I'm just using a match statement as essentially a state machine here. Super nice to do for embedded systems. Okay, so what else do we have? We're going to have, what are our other states? Grab. Or if we have a grab that has 0 left and n, well, we have a grab, we have an OXOO. Let's just be consistent. Then this means we have an okay sum, and then it's either going to be destination index or destination index minus 1, self dot destination index. So that's how many bytes we've collected. So we've got an okay sum, and then our state is just going to be, what is that? Error or complete. So we've completed. So if we get a grab with I guess grab 0 with OX FF, that means the next one is going to be an okay not none. And we're going to start a grab chain OX55, probably getting FF in a lot of these positions is going to be that, but okay. And if we get a grab with any other number, grab I n. So this says that we still have bytes to grab because we know it's not 0. Oh, no, we got one more. Grab n. Then we still are in okay, none. And we're going to do a grab n. Now if we have a grab I n, that means we're still grabbing things. So we're going to have an okay, none. And it's going to be grab n minus 1. So we just decrement that counter. So that's grab. I think grab chain is actually going to look surprisingly like that. So let's start by cheating. Nope. Grab chain. There's probably something, actually, probably. Here's the only place that we've gotten real data. Let's see. If we grab 0 and there's a 0, this is the end of the message. FF means we're about to start a grab chain, which, if we're in a grab, this means that what we just got should have been a 0. So add, I have this little helper function called add where we give it self.dest. Index is going to be self.dest index, and the data is going to be, let's see. Now, it's not actually here where I want to do this. I want to do it. I want to do it here. Okay, so this means that I got the, I probably need another function here that doesn't do it like this. Add. So this fails, then we return an error. Otherwise, we have successfully pushed one item back. And then we need to do a self.dest index plus equals 1. And then we can return this. Okay. So, and then if I grab and there's something left, then this also needs to get pushed. Actually, what I'm pushing here is not n, but 0 actually. Oh, thanks for that. This one, I am grabbing n. This is not n, this is I minus 1. Boop doop doop. Convert from not usize. Index should be usize. Self.destination index is a usize. Oh. Mut U8. So destination is a self mut U8. Self dest index, which is a usize, and that's what we're passing in, and then the data, which is a 0 U8. I don't know what it's complaining about. Oh, that's what it is. It's because the return type of this doesn't match that. Which kind of defeats the whole purpose of what I was doing there. Dot map error. Oh, Bionic Bits is talking to me. Yes, I am watching my stream. You're probably very frustrated by what I am doing right now, because I am jet lagged and I am not the most effective coder right now. Single tuple, but take 0 arguments. Right. Hey, that actually works. Non-exhaustive pattern. Yep. That's because I'm not done yet. Okay, so I should probably make these look like this. So grab 0n is the important one, because we're going to do essentially the same, because if we have data, this is funny because the pre-stream, so before I actually streamed and recorded it, I just did a like a chat, and what I was doing then was also building a framing parser, but the other one that I wrote was terrible, and had a ton of overhead, but it was really easy to write. I just used the words start and end with a square bracket as my actual beginning and end of message, which was probably not the most efficient, but it totally worked for the demo that I did that day. So if I get to grab a chain and there's 0 left, actually what we need to do, and error complete. Where's the one where I push 0? This is the one where I push 0. This one actually shouldn't actually do anything, because at a chain there's always going to be an extra. So this one is just going to grab the next chain, actually. That's the difference here. The grab chain IN, where there is data left, it should so that's going to be like that. So if there is I left, this is not going to be grab, but this is going to be grab chain of I minus 1. So add it. If it worked, increase the destination index. Great. so I think that's all of grab chain covered. So what else do we have to do? Error complete. So if we're in error complete, return an error of self.dest index tuple of what the next state is. Match state. State is what the second thing you return. Still in error complete. Just latch the state. Expected type. Found enum decoder state. Did I screw that up? What am I doing? Error. Right. Because actually it doesn't matter. If we're in an error state, you can have any data you want, but we're done. Okay, so now this is our little state machine where we exhaustively figure out all the things that we should do, and then push just enumerates, and then I feed it and this returns two U sizes because it's how much of the source have we consumed and how much of the destination we've consumed. Or if this is the one that finished it. So let's say you put like 10, 20, and 30 in there. And in the 30, you only use 10 to actually finish it. It's important to know that I've only used 10 of the incoming stream, so those next 20 can be used for their message. And then this is going to be how much of the destination buffer you've used. This is how much of the source buffer on this iteration you've used. And tuples are wonderfully convenient and terrible for documentation. Let's see if I managed to fix the tests, or if the tests are still upset. No, tests are still very upset. COBS decoder. Destination 10, 11, 2, 0. Dest index 4. Called unwrap. So what happens if I call this just one specific one? So specifically, I'm looking at test encode 3, which should be pretty simple. It should give a 255 and a 0, and should give back a 2, a 255, and a 1. Where is it panicking? It's panicking at test 75 or 74. Tests 75 or 74. 75. So there's just some panic in here. Awesome. There is a closure. That's not very useful. We can always step through this, but that's okay. The decoder is what panicked, and it's got 255 and 1 in there. Which it should not be 1. It should be 0. Okay, so Rust GDB Q2E target debug test. Then this is what? Test encode 3. B test encode 3, and let's run. Trying to debug what's going on, but multi-threaded code is, and when GDB is not cooperating. Burp, burp, burp. Okay, let's take a look at our code, actually. So we're just going to do some visual debugging. So if we were for I data enumerate, so n equals feed d let's print three things. We're going to print ID itself. Okay, let's go back to just running that. No capture. Okay, whatever. It's going to fail. It's not going to capture the output anyway. Did I just do a print, not a println? Println. Okay, so 0, I makes sense, D makes sense, it gets 255. Two 255 1 COBS decoder decode tab, so then I put in a 0. My destination is that. Why does my destination between here, well no, I guess this is, okay, if it's 2, so before it goes in it was idle. So it's going to have a grab 2, and this theoretically should be, by the time we get the 2, because the 2 is in there, so 255 is going to have 2, so it's going to go 1, 2. So we feed it 255 and then 1. So that means that we should be in grabbing, because when we put that in, or it's grab 2 before that, it's grab 1 when we grab 1. So I need to do 1, 2. So I think it's not actually, what if I do, I think this might be off by 1. Where does that 1 decide to come from? Is it just putting that in there? Okay, you know what? Let's break on. Let's see, because it's grabbing, and if we're in the grabby, we should return okay. Let's just, before we, let's just do an after. Data self. This is really hitting it with a hammer. I'm not sure what I'm doing wrong here. I probably should get my debugger working, but parallelize debugger. So after 2. So the data that we pass in is going to be 22551. So after we've passed in 2, our destination is 255 and 0, but our index is 0, which means essentially this was just junk that was already there. And our state is idle. Why is our state idle? Because we just grabbed something. Because when we idle, n should become a grab n, because we had y grab if it's idle and it's 0, but the thing you just gave me, am I feeding the wrong thing in? Like, is it feeding in 0? Decode tab I and D. Decode tab I and D. D is 2, very clearly. After 2 COBS decoder, destination index. Y is your state idle. Well, that's definitely the problem. So what causes my state to end up in idle? Really just receiving a 0. But that doesn't make sense because we printed it. Okay, what if I just do big 4? Before 2, it was in the state idle. Why does giving it 2? So I'm in the state. I'm in the state of idle. And I gave it a number that wasn't 0 or FFF. It's data. Data is a U8, but this seems to not be giving it U8. No, I guess it is using it U8. What if I do this? I really just want to step through this. Oh, right. It's not self. That's what I wanted. Or I did want this, but I wanted this here. Because it is updating the state. I just printed it. Bionic Bit is asking about hotels. Let me go off the stream. I have a PR open on the Oxidize website to talk about hotels. But for right now, actually, well, yeah, okay. I use GIST for more than what I should. So let's take this gist. These are the hotels near the event. It's on public transit though. The U-Bahn. So if you pick anything on the U-Bahn, Bomb. You should be fine. Okay. Also, I probably shouldn't respond in chat, but oh well. But yeah, this is that gist, and hopefully you won't need this because in a day or two, the Oxidized Conf website will have this. We're adding a logistics page that has all of this, and we'll probably add some other stuff like how to get around Berlin and things like that. It's weird. It's hard to recommend a hotel in a city you live in because you never stay in a hotel in a city you live in unless you have like family come to visit or something like that. So I'm just hopeless at recommending hotels. But we went and looked at hotels very close to the conference, and these ones looked good. But yeah, we don't have an official partnership with anyone. So why is this not actually working? Before, after. Okay, I was in grab 2. Let me get rid of whatever that decode is, because that's cluttering us up. Let's maximally print debugging this. Before, after, grab 2. Before, after, grab 1. Before 1. See, that's still going down, because when it hits grab... Yeah, I think these all need to be... I think I put it in the wrong place. I think if I can do this... Because 1 means you're done, because the next one's going to be zeros. Because this I would expect to have oh, 255 is still right, and that is right on an error value. Where am I getting that error value? In the test RS13. Okay, where's test RS13? 13 decode.unwrap. Okay, something's propagating out an error, so let's go actually look at our... So when we call push, burp, burp, burp. This is definitely professional print line debugging. Okay, what happens if I run U now? Do I get like a happy? Okay, none. Okay, some. Okay, some is great. Return okay, some. Okay, so what do I call push? Ugh. Do I still have some garbage in here? So I create a new decoder, I print. Okay. Good test. Did I get like my... I probably got my arguments like the D used in source mismatch. Okay, that would have been helpful if I had printed out the two numbers. S used source dot then, right? Source dot len may not. Well, no, it should have used all of source. Source mismatch 0, 3. No, of course, because I'm pushing 0 in there, so that's definitely not going to match. Yeah, because I push 0. So yeah, that's okay. I don't know why I was doing this extra. I don't know why I was doing this extra check. It didn't make sense. I guess it was to make sure that we used the right number of things, but burp. Some tests failed. Okay, well, you know, some tests were passing. That was nice. So what failed? Just one? Encoder round trip 2. Okay, are either of you easy tests? I think round trip might actually be a round trip 2. Okay. Ooh, you know what? We're gonna turn off backtrace, and we're gonna t minus a test.log. Okay, so now let's go look at that test.log. Arm test.log. Let me make sure I have a fresh one because I use test.log a bunch. Okay. Let's. Oh, yeah. This before after is probably bad. That might be what we need though. View layout single view no word wrap. Let's go down to the end where it. Can I just look for the word fail? Failed, fail. Left equals right. So left is 0. So test round trip 2. What does test round trip 2 look like? Test round trip 2. Okay. Which is test round trip, which source essentially, okay, it's just source and decoded. Source and decoded should look the same, and it's source first and then decoded. So the source should be 0, 1, 2. So I seem to have this is because mine are you it's because mine will throw away leading zeros because it assumes that that is unacceptable. But once you've encoded it, the encoder shouldn't throw that away. It's really one less. So why is my encoder throwing that away? I boycott NH. Is there NH hotel groups or something like that? I know that's a chain of hotels. I don't know what they did at 43C3. Probably you mean 34C3. I think that was this year. What did they do? Yateki is saying I boycott NH for their shenanigans at 43C3. What shenanigans did they do? while I try and figure out how I lost a 0 somewhere. Let's see. Does it have the line on this? No, I probably do want the backtrace. But I only want, I want only test round trip 2. Test line 21. Line 21. Source decoded. Source has 0 in it, and decoded does not. So what would make it throw? Because it should only throw away if there are unencoded zeros there. If you just have the data, this is one of those where I thought this was going to be pretty quick, but I don't understand protocols. It's probably, I'm going to blame it on sleep. It may not actually be sleep. This is going to have just everything in it, isn't it? So that's 152 or 252. So it's not taking a number at 0. So is my grab, in my grab, decode, if I have a grab and it's 1 and the number that's there is n, I add 0. Okay. Before 1, it has nothing in it. After. So I should have the leading 0. And I have the 1. Huh. Because I put 0, 1, 2. Is that what it's supposed to be, or is it not supposed to be that? Because it sure as heck looks like I have the leading 0. Test round trip 2. I still have the leading 0. Is the leading 0 what I should have? When did you become not? D. Oh, E and D. So that's decoded. 0, 1. Encoded. So this is the last one. 1, 1, 255. Okay. Grab 1. Before. So we were in a grab 1. We were in a grab 1. And we get this. If we were in a grab, then we still need to insert the 0th item. So this needs to be up here. And I bet you grab chain no, if a grab chain goes into another grab chain, you don't need to insert. Actually, grab chain never inserts anything in the output in the decoder. So now if I run cargo test, thank you for people who write test suites so that when people mess with your code, then they can make sure they don't screw anything up. Because now I can make sure I don't screw anything up. So we're going to commit. Update. Noisy, but the decoder seems to work. Cool. Okay, I'm sure I could refactor some shenanigans here, because there's probably some duplicated code here. Like, well, I mean, it is and it isn't. Whatever, it's okay for now. Let's just get rid of all the prints. And I gotta get rid of all these super ugly map errors, because that's just not great. Print. Yeah, SUs is not super handy there. I gotta figure out what I want to do for the API of that. Okay, so that's all there. Yeah, I do a bunch of these, like, because I want to be able to return a result. I guess those really are okay. That add function's ugly though. Add to. Two dot. I guess this is really all just. Burp derp. This is what add. Get mute, okay or else, data, yeah, this is just going to become self.dest.get mute self.destination index no, because that's some or none. So I guess I do still need that okay or else. That's kind of annoying. Alright, we'll leave it in there. Okay, well, I should probably wrap this up because it is getting late in Berlin and we didn't get to do everything, but that's okay. Let's clean this up and make this into a PR. So we've got this. Let's look at all these map errors. How many map errors do I have? Oh, those are unfortunate. Push has got its own. I guess this is the only place that I use add. Yeah. Let's let if we let dest index, what is this, val equals, let's just take dest.get mute index dot okay or else. So this gets us from an okay to an error type, and star that equals val really I just need this to be self dot dest index. what happens if I replace add or bail? Type annotations needed, and mut u8. Type annotations needed for T. All right, you know it. You know it. I guess it's not so bad. I'm sure I am missing some tiny little chained operator or something that makes this work well, but it is too late for me for that. But yeah, I guess this is 0. 0 should be an error because it means that we have grabbed too many. Or I should just start with one lower number, but you know what, let's do that while we're at it. Let's do grab with one lower number. Because, you know, off by 1 isn't. So wherever I return grab -1, grab chain -1. It's only when you first create them. So if we're in a grab chain, then we don't do it, but it's really only if we're in idle E. And if we're going from idle into a grab and -1, then if we're going from a grab into a grab chain, XFE, going from a grab to a grab, if we're going from a grab, no, that's just a grab to a grab. It's really only zeros or idles. So grab chain 0, FE, grab n -1. Okay. That's a dense state machine. But yeah. Let's see. Do I really need the enumerate? I do need the enumerate if I need to know what item is in there. Hopefully Rust will be smart enough that if you don't use the enumerate, it won't actually use it. Let's put some comments in there. Create a new streaming COBS decoder. Provide the output buffer for the decoded message to be placed in. Push a single byte into the streaming COBS decoder. Return values mean. Result none. State machine okay. More data needed. Result sum n. A message of n bytes was successfully decoded. Result. Excuse me, result. These are all results. Okay. This is error M. Let's see. Message decoding failed and M bytes were written to output. This is probably unnecessary to have, but that's okay. Let's just steal that. Push a slice of bytes into the string COBS returns value mean. So if we have an OK, none, state machine OK, more data needed, sum n m. Let's see, it is a message of n where n is map error. So message of n bytes is successfully decoded using m bytes from data. And earlier data. NM J. Oh, just error. Message decoding failed. I guess if you want to say how many bytes were written to output, that's probably a thing that I should do. Size error J and J bytes were written to output. Look at my huge cursor. I don't know why I have a huge cursor. I blame i3. So decode. Can I replace any other ones? Is it necessary to replace any other ones? Huh. Okay, let's go. Destination slice for decoded message. Current or index of next byte to write in test. How does it go with UART? We haven't even gotten to the UART. We are coming up with a theoretical framing for our UART, Yateki. Current state. This is a useless comment. Decoder state as an enum. Yeah, so Yateki's asking how it's going with the UART. The UART is not going at all yet. The thing that I wanted is I wanted to be able to have a streaming framing. I wanted to have a streaming encoder and decoder for framing for my stream of bytes. And I ended up writing a giant state machine that took me way longer than I thought to write a giant state machine. But I'm cleaning this up now, and I'm going to I am going to submit this as a PR, hopefully. So create a new streaming COBS encoder. I'll leave that to do in there. Push a slice of data to be encoded. Returns. Let's be consistent. Returns. How do return values mean? Return values mean burp burp burp. Okay. Data was pushed successfully. This is I guess this is straightforward. This is if destination index equals 1, return okay 0. I guess, do I put a 0 at the end of this? I guess I don't put a 0 at the end of this. What do I do for encode? Alright, that's because his doesn't put, or the original author's doesn't put a 0 in there. Complete encoding of output message does not terminate the message. Does not terminate the message with which the sentinel value. Sure. This that's fine. Decoder, I should probably specify what you do. Feed, push. Note, sentinel value must be included in the input to this function for the decoding to complete. Let's do that up here too. Okay. Push. Do I need to code anymore? Probably, because I can't decode in place. Because I can't have two mutable buffers of the same buffer. Here's my streaming encoder, kind of expects that you do that. Well, we'll see what they feel about that. Okay. I feel like I left this better than I found it. So git add -i. What? Oh. cd Ferris Internet of Streams vendor COBS git commit clean up code for PR push origin streaming. Okay, well, I should have a PR. Pull request, new pull request from compare Ferris systems cobs.rs. To the head branch, streaming. No. System slash COBS. Okay, streaming. Let's change this. Edit base. Okay, whatever. Close pull request. New pull request. Master from streaming. Create pull request. Closes 5. Streaming encoder decoder should work even for no stood targets. And actually, let's go to their Travis YAML, and let's do another good deed while we're here. Let's edit this. Are they not actually testing anything? Cancel. Is there some test that I don't see? I guess maybe Travis automatically runs a cargo test. Sure, let's give them this. So this is my handy way to make sure that no standard works. So let's give them a script. Cargo build, cargo test, cargo build, no default features, target equals ability by building for an embedded target. Add no stood check explicit testing. Pose file change. This create pull request. Create pull request. I guess it's probably building my other PR too. Okay, well, hopefully that is wrapped up, but I think it's time for me to be done for the night. Cool, that built. Did this actually build anything? Does it just implicitly build that? Or did it just like run a no-op CI? I'm not an expert in Travis. It did take some time. Oh yeah, I guess it runs an implicit cargo test. That's nice of it. Okay, cool. Well, my code passed. All right, well, that has been a stream, and thank you all for joining. Today we got our framing done. So next is going to be working on the UART, getting that ready, and then it's going to be putting it all together in this kind of format. So eventually I'll have messages coming out of my serial port that look like that, and we will be set up for doing things. But today we have this, which is nice. Okay, thank you all for watching, and I'll see you next time I'm streaming.